Hello, and welcome to EELE 101 Introduction to C Programming. This week we will be looking at assembling your race car. And here you can see a picture of the front end of the race car that we've assembled. Okay. Alright, so your car is going to come in a box that may or may not look like this. This is actually one of the older packages, so it may not look exactly like this, but inside you'll get the race car with a bunch of parts. And so here is what it looks like with all the parts in the plastic bags. So just bear in mind that things may not be exactly like this as things progress in the future, but this should give you a good enough idea of how to put this all together. Okay, so a closer view of the parts, and then we've actually laid out the parts that have come with this particular kit. One thing that you should notice is there are extra parts. You won't be using all the parts on the assembly, and we'll just show you which ones that work. You don't have to do this exactly, but it's suggested that you follow along and do this. Alright, so there's a couple yellow connectors here. These are the connectors that we will be putting on the servo motor. So we need to um, get these three pieces, okay, and this is what will ultimately connect through the tie rods to the front wheel. So here's a view of the three parts that you'll put this ring on this connector and then actually flip this one upside down, and here's a spot where a screw can go in and we'll connect it to the servo motor. Alright, okay, so before you put the servo motor on the car, one thing that we need to make sure is that we know where center neutral is. We don't want to connect this all up to the car and have it already turned full right or full left, and then send a control signal where it wants to, try to turn beyond what the car can do. Okay, so there's a test and verification procedure we need to do to ensure that the servo motor is where we think it is before we put it on the car. Okay, so this is what we will show how to do next. Okay, but first, how does the servo motor work? Okay, so here I've sort of borrowed this picture from Wikipedia. This is a typical configuration for a remote control car or airplane or what have you. Here you typically will have some sort of let's get this back into pen mode. Okay, so you'll have typically a receiver. Here you can see the antenna over here, and the battery will power this receiver, and then the receiver can actually control a number of servo motors. Here we just have the battery power comes here. So here we have the servo motor coming out here, and there are three lines. Okay, one is going to be ground, one is going to be power, and one is going to be the control signal. Okay, so what we're going to pay attention to here is that control signal line, because this is what tells the servo motor what to do. Okay, so the signal coming down the control line is what is called a pulse width modulated signal. Okay, so this is pulse width modulation. All right, so for servo motors in RC systems, okay, the control signal are these pulses that show up every 20 milliseconds. Okay, what changes is the pulse width. Okay, so this is telling the servo motor how to turn. Okay, if the pulse width is 1 millisecond, okay, like down here, okay, the servo motor is going to be turned all the way to the left. Okay, if the pulse width is 1.5 millisecond, okay, as in down here, right, okay, the servo motor is going to be pointing straight ahead, or will be in its neutral spot. Okay, so this is what we will call center neutral. And then if the pulse width is 2 milliseconds, the servo motor will turn all the way to the right. Okay. What we need to ensure before we put the servo motor onto the vehicle is that it's in the neutral position, or center neutral, because we want to make sure that it's would be steering the car straight ahead. So we don't know how this got shipped from the factory. That may be correct, it may not be. So we need to make sure, okay, we need to verify that this is indeed in the position we think it is. Okay, because if we don't, we run the risk of damaging the motor and maybe our vehicle. Alright, okay, so the first thing you'll need to do is get the battery so that connected to your shield. Okay, so actually at this point a good thing to do is actually unpack your battery, okay, from the packaging, and actually plug it in to the charger, because you'll want a fully charged battery. So you should do that now. Okay. Then there's a battery connector that comes, and we will plug this in to where the power goes into the board. Okay, so that's this center connector. Notice you have something called VBAT, or the battery voltage, and you have ground. Okay, so connect the red wire to VBAT and the black wire to ground, and you'll notice that you'll need a small screwdriver to loosen it up, put the wires in there, and then tighten it back down. Okay. All right. Now, one word of caution here is don't try powering motors when your Freedom board is plugged into your computer through the USB connection. All right. Okay. The reason is that the USB supply, from your computer doesn't have enough power to power your motor. It can't supply enough current, right? And if you try to run your system while connected to your computer, you run the risk of damaging your computer. So only use the USB connection when you're downloading code to your board, and not when you're running motors. Okay. So if you run motors, make sure you're only connected to your battery. Alright. Okay, so last week you ran a demo where you could blink LEDs. Okay, well, part of the same demo, and this is now demo 1, and to get to demo 1 you need to turn switch 2 on. So you're using the same switches again, and it's the same 2 center switches, but now turn switch 2 on and all the other switches off. So actually don't pay attention to this particular configuration because that's not correct. But that's where you need to set it. Okay. All right. And what we want to measure here is actually the pulse width modulation and the pulse width modulated signal that will be sent to the servo motor. Okay. So we need to connect this up to an oscilloscope. So take your oscilloscope probe and the ground clip, okay, which is this one here. Okay, on the shield there's a little ground post, okay, that you need to connect to. So connect it to there, and then the oscilloscope probe on the connector that goes to the servo motor. Okay, on this rightmost pin is where the pin is that outputs the PWM signal. Okay. Now, there is also a ground pin right here. Okay, and you may be tempted to put the ground clip of your oscilloscope probe there. Okay, that's actually not a good idea, because guess what? This pin in the center is power. Okay, and this is the power to the motor. And if you actually tilt your clip a little bit and short these two pins together, you will create a short connection. There's a lot of power that can then run through your board to ground and back, and you could blow up a trace on your board. So it's actually best to put your ground clip over here, away from where it could potentially connect to a voltage pin and damage your board. Okay, so once you've connected the oscilloscope probe up, okay, what we want to do then is actually look at that pulse width modulated signal, and specifically we want to measure the pulse width. Okay, so on the scopes that we have in the lab, which are these Tektronix TDS 3012 oscilloscopes, okay, we can do this by pushing this measure button that's over here. Okay, a menu pops up, and over here we can select sometimes if you need to push more. So no, I think this is, you have to push this more 3 times because this is on the 3rd one here. But here you'll see positive pulse width, and then you select that, and then down here you'll actually see the pulse width being measured. And of course you'll have to do other things like setting the trigger, and if you need help with that, you can ask the TAs. Okay. So once you can start seeing the pulses and you're getting a measurement of what that pulse width is, then adjust the pulse width by turning this blue knob here to get a pulse width of 1.5 milliseconds. And as you recall, this is the pulse width that we need for center neutral. Alright, so once you have your board putting out a 1.5 millisecond PWM signal, okay, so unplug your battery pack, remove the oscilloscopes, okay, now connect the servo motor connector, okay, and connect the black wire to ground. So make sure you get the signal connections correct, and then plug in the battery pack, and demo 1 should start running automatically. It should start sending out that pulse width to the servo motor that is now powered through your battery pack, and it should immediately turn to center neutral. Okay, so don't turn the blue knob in between, because we need the 1.5 millisecond control signal sent to the servo motor. Okay, so once that's happened, okay, you can unplug your servo motor, okay, and then attach that yellow connector that you created to the servo motor so it's perpendicular, so it'll be upright, and that's where you will connect the tie rods to your wheels and that servo motor. Okay. The other thing to bear in mind is don't force the servo motor by hand, okay, because then you can damage the servo motor itself and the gearing inside. All right. So now that we've set this servo motor, so here if you've taken off, you don't know where neutral is, but now that we've set this to center neutral by sending the 1.5 millisecond control signal to it, we can go ahead and now attach this yellow connector to it, and we know that this is in the position it should be. Okay, So now you can get these black connectors. You'll connect it up here because this actually will then connect to, this is how it connects to the vehicle. It's actually connected on the other underside. All right, so this is the part here. You can see here that's actually a screw comes up from underneath the vehicle and attaches the servo motor. All right, so here we can see that the servo motor has now been connected to the car. Okay, and then the next step is now to get the pieces that are part of the tie rod and connect the servo motor to the front wheels via the tie rods. Okay, so you'll have to screw those in. Right, here's kind of an easy way of doing it, just by using screws through the holes here to turn it. Okay, and if you're just want to get a ballpark of how long these should be, okay, we just here measured it with the micrometer. This is more just for illustration purposes, but if you want to measure it and do the same thing, this worked for the car that we put together. All right, getting that silver ball positioned in there, to snap it in, you'll want to use some pliers. Okay, and then the screws go through and attach it to that yellow piece in the servo motors. So here you can see the front and back of how we did that. All right, so here's a view of the completed front end, and this is what you'll need to do yourself. Okay, and here you can see the reason why we need to make sure we know where center neutral is, because if we have this yellow piece sticking straight up, this better be where this position is when a 1.5 millisecond signal is sent to it and not some other signal. Okay, so that's why we had to make sure that that was the case before and measure that on the oscilloscope. All right, so here you can go ahead and put the battery on with these tie strips, and then what we also give with the kit is this setup where you can now attach your board. Okay, so this shows you kind of where you can connect it on the vehicle. All right. What also comes with the car is the line camera. Okay, also be aware that there are screws here that on the other side of here is this black plastic piece, and this is how you actually connect it. It's easy if you're not paying attention. These screws are actually in the corner of the bag, and if you don't get them first and toss the bag out, you could lose them. So just make sure you find those. All right, but a big word of caution here. These connectors are not keyed, so you can put these in backwards. If you put them in backwards, you can destroy your camera board. Okay, so don't do this. All right, so put black on ground, and ground is on this side. If you flip the boards over, you'll see that here's a ground pin, there's a ground pin. Make sure black is connected from ground to ground, okay, which means that power will be connected to power and whatnot. If you get this backwards, you can ruin your board, so pay attention to this. All right. Okay, so the other thing you'll need to do is actually mount your Freedom board and the shield to your vehicle. We give you some plastic plates. You'll have to actually create the holes. In the lab, we have some punches that we can do this fairly quickly, but you'll need to mark where you want them and punch the holes. Okay. Then you'll need to connect up the motors here. Okay. So that's how you actually connect up those, right? And red goes to B2 and A2, and ground is B1 and A1. So that's the black ones over here, ground. Okay. And ultimately, you will have your vehicle assembled. Okay. So for this week, your assignment is to demonstrate that you can get a 1.5 millisecond pulse width modulated signal. Okay. And then you'll need to plug your servo motor in to actually get it turned to that center neutral position. Okay, so this is what you'll need to demonstrate in the recitation section. Once you have that, then you can go and attach the motor to the car and the tie rods to the car. And that's for week 8. Actually, the next week we'll be finishing the assembly of your car. But for this week, we want to make sure that you get the servo motor in the position it needs to be before you attach it to the car itself. All right, that's it for this week, and good luck assembling and measuring.